Hey, what's good? Got a quick question for today. This is thermochemistry once again. So I guess we'll just get into it. So we want to calculate the boiling point. Wait, why does it have boiling point? One sec. Point of a compound. How are we going to find this? Well, it's kind of similar to the question that we did yesterday, in that like we found the change in H, change in S, and then we solved for T because change in Gibbs energy had to be less than 0, but that was range. Now we need to find the specific boiling point of the compound, and we have both change in G, we have delta H, delta S, or like delta enthalpy, delta entropy, and now we just got to find the boiling point. So first thing we'll do is just write out that one equation that connects all these together. So we know this, we know this, we don't know this, and so far we're not too sure about that. So boiling point of a compound, that means when it's going from, wait, let me just rephrase that. So what does it mean when we're going from boiling point to, like, what does it mean by boiling point? What does it mean by boiling point, bro? That's what I'm trying to say. Boiling point is when we go from liquid to gas, yeah? Liquid to gas. This is the boiling point, so liquid to gas. Now, something, I guess, like a fact that you would know is that as at phase equilibrium, or like boiling point, freezing point, things like that, the change in G will always be 0. Now, what is the reason for this? Well, if we rewrite this equation, it kind of makes sense. I just learned, I don't know, I didn't learn this earlier. I just talked to ChatGPT before doing this video, but what happens is the amount of energy that we put in, so that's like enthalpy, right? The heat, that kind of energy that we put in, that'll be offset by the gain in entropy. You know what I'm saying? Does that kind of make sense? Like we lose energy to heat, right? So it'll go into here, but then we gain that energy in entropy because, gas has a higher entropy than liquid. Gas molecules have more random movement while liquid is less random movement. I hope that makes sense. Because, we're losing the energy to heat. That's the heat that we're putting in. But then we're also getting that energy back in the form of entropy. So that change will cancel out and it'll result in change in G being equal to 0. So hopefully that kind of made a bit of sense there. So now I guess we could just substitute these values in. Other than the fact that we need to establish other than the idea that we have to set delta G equal to 0, all of this is just substituting in values and it just makes sense. So delta G equals 0, delta H equals 29 point, oh wait, we need to make this joules, 29,600 joules minus temperature. Oh wait, maybe we'll just isolate for T first so it's easier. What's delta S? So 0 minus, these will just cancel out. Now 29600, just divide those two. Where was my calculator? Can you try me? 29600 0 divided by 93.6, 316.2. And there you have it. That's the answer. Temperature of vaporization is equal to 316.2 Kelvin. So yeah, that's all for today. I'll see you tomorrow.